Class example 4.43. Determine an equation in both factored and expanded form given the graphs of each of the following functions. So if we look at A, let's start just writing down what we know. So I'll start off by writing f of x is equal to, and now I'm going to split this up between the numerator and the denominator. And then just remember that in the numerator, that would be where we have our factors that represent the x-intercepts. And in the denominator, that's going to be our vertical asymptotes. So if we look at the numerator, in this situation, we don't actually have any x-intercepts. So I'm going to leave that blank for a minute. And now let's look down at the denominator. So we have a vertical asymptote at x is equal to -2, right there. And x is equal to 4. So let's write those in. So the x is equal to -2 would be x plus 2. And the x is equal to 4 would be x minus 4. All right, so we have that part down. Now, you might expect that it's a 1 on the top. And that could be it, but we don't really know because this graph, even though it has those asymptotes there, it might be stretched more than it should be, like up and down this way, or it might be squashed more than it normally would be, or it might be reflected, even though this one's not. But in order to find out what that stretch is, we have to determine what the stretch factor was there, what the vertical stretch factor was. So A. All right, so now we just need to solve for A and then we're done. So it would be nice if we knew what the value for y and x was, because then we could just throw those values in and solve for A. Well, it's a good thing that they gave me a value for x and a value for y. This is going to be quite often the case that they'll explicitly give you a point on the graph. That being said, you could choose any point that you know is on the graph, but this is common to actually show you a point. So let's use this one. So we'll throw this in. So there's my x and there's my y. So instead of f of x, I'm going to write the y value. So this will be negative, and I'm going to write it as a fraction. So -1/4 is equal to a over, and then x would be 0. So 0 plus 2, and then 0 minus 4. All right, so now we have -1/4 is equal to a over -8. And then we will multiply both sides by -8. So in the end, we end up getting 2. -8 over -4 is 2, so that's 8. And then last step, we're just going to throw this value for A back in. So now we'll say f of x is equal to 2 over x plus 2, x minus 4. All right, so now that was in factored form. So just the last thing we're going to do is write this in expanded form. So that just means we just need to expand that the factors in the denominator. So this would be f of x is equal to 2 over, and then this would become x squared minus 2x minus 8. All right, let's take a look at B. So again, we're just going to start filling in what we know. And this time we have our x-intercept, so that's just going to change it up a little bit. So let's just start by writing out f of x is equal to, and again, I'm going to split this up between the numerator and the denominator. And in the numerator, that's where our x-intercept factors go. So we have an x-intercept at -1 and 2. So that would look like x plus 1 and x minus 2. All right, and in the denominator, that's where our vertical asymptotes are going to go, or our non-permissible values. So we have a vertical asymptote at -3 and +3. So that would look like x plus 3 and x minus 3. All right, so that is the general form of this graph. Again, the only thing we don't know is how much this thing has been stretched upward or squashed down or reflected, right? So we're going to have to figure out what the A value is, what the stretch factor is there. So we'll do the same strategy we did last time. We're going to use the point given, so this one. So they gave us an X value and they gave us a Y value. So we're going to fill in the f of x, or the y, with negative 4 over 9. So negative 4 over 9 is equal to a times, and then our x values are 0. So 0 plus 1, 0 minus 2, over 0 plus 3, and 0 minus 3. So cleaning this up, we have negative 4 over 9 is equal to, and then this would become negative 2a over negative 9. Now, just so we don't confuse ourselves with the negatives here, let's just drop the negatives. So this is negative 4 over 9 is equal to, and then 2a over 9. All right. Multiply both sides by 9. We get negative 4 times 9 over 9. So those cancel. Is equal to 2a. All right, divide both sides by 2. We get negative 2 is equal to a. All right, so now, again, we'll throw this back into the original for a. So we'll have f of x is equal to negative 2 times x plus 1, x minus 2, over x plus 3, and then x minus 3. All right, so now that is in factored form. So the last step will be just to expand this out. So in expanded form, we have f of x is equal to. So now what I'm going to do first, just one step at a time here, I'm going to expand this negative 2 into the first factor here. So this would become negative 2x minus 2, and then put that back in brackets. And then we still have to multiply that by x minus 2. And then that's over, and I'll just write this again, x plus 3, x minus 3, and then I'll expand everything on the next step. So now we have f of x is equal to, so this would become negative 2x, just doing our first one there, 2x squared rather, and then plus 4x minus 2x, and then plus 4, all over. And then the end here, expanding this one out, this would be x squared minus 9. And then the last step here would just be to collect those like terms. So now we have f of x is equal to negative 2x squared plus 2x plus 4, all over x squared minus 9.